It's striking how certain mid-century experiments linger long after their findings fall apart. Writing in early June, Claire L. Evans looks back at the planarian worms of the 1960s, creatures once thought to transfer memories through cannibalism. While those specific results dissolved under scrutiny, the search for memory outside the brain continues in the stranger corners of biology. Then Ian Bogost, in a piece from just this week, turns to the famous marshmallow test. Instead of trying to fix the science, the focus shifts to the toll of the delayed gratification cult. There's a puzzle here. When a scientific myth breaks, does it reveal a hidden biological mechanism or a flaw in how we measure a successful life? Earlier this month, Claire L. Evans followed a researcher to the frozen banks of the Charles River as he hunted for a specific type of flatworm. It's the starting point for a look at a strange, nearly forgotten chapter of 1960s neuroscience involving cannibalism and memory transfer. Notice how Evans uses the physical frustration of finding these wild worms to set up a larger question: whether memories can survive in cells rather than just synapses.
Are memories transferable or edible? Introduction. It was the dead of winter in Boston. The surface of the Charles River was frozen solid. But Zachary Kelso braved the biting cold to finally put to rest a mystery that has haunted neuroscience labs for over half a century. To do that, Kelso, a research assistant in the Harvard lab of the neuroscientist Sam Gershman, needed some worms. Specifically, planarians, arrow-headed flatworms, which are among the simplest creatures to possess a brain and a nervous system with bilateral symmetry like ours. Normally, labs order these widely used model organisms from biological supply companies, but the mail-order worms weren't up to snuff. So Gershman had dispatched Kelso to the Charles' icy banks to catch some wild ones. I thought, I'm going to look crazy because I'm using a hammer to beat through the ice, Kelso recalled. So I wore the more business end of business casual. It wouldn't be the last time Kelso found himself in this situation. The Charles River planarians, it turned out, didn't cut it either. Neither did the worms he sourced while stream hopping around Eugene, Oregon in March 2025. Nor did the ones he fished from Michigan lakes that June, this time in thigh-high waders, while picnicking families gawked from shore. Kelso diligently turned over rocks, angled with bits of meat tied to a string, and even followed maps from a vintage guidebook called the Freshwater Triclades of Michigan. But his adventure was fruitless. Sure, he caught plenty of planarians, but back in Gershman's lab, none of them would do what they were supposed to do. In the 1960s, an eccentric behavioral psychologist named James McConnell convinced the scientific establishment that planarian worms, like Pavlov's dogs, could be classically conditioned, and that memories of this training could be transferred from worm to worm through cannibalism. These bizarre findings were replicated by other scientists, and worm training became a staple of high school science fairs. Now, 60 years later, the worms have stopped learning, and nobody knows why. I first learned about this scientific mystery while reporting another piece for this magazine about what a cell can remember. As I dug into the historical literature on memory research, I kept coming across McConnell's strange worm experiments, which captivated a generation of scientists before disappearing entirely. Planarian memory had itself been forgotten.
I was content to dismiss it as a fluke of history, until Gershman mentioned, in passing during an interview, that in addition to their work with the unicellular ciliate, Stentor caeruleus, his lab was attempting to reproduce some wacky worm experiments from the 1960s. Had I heard of them? Gershman, I learned, was keen to pick up where McConnell had left off. As part of a growing cohort of cognitive scientists looking beyond the brain for clues to the origins and basis of memory, he's fascinated by any creature that seems to remember without the benefit of neural synaptic networks. Little Stentor caeruleus, for example, can modify its behavior based on previous experience. Quite a feat for a single-celled creature that can't possibly have a neuron. Planarian worms, if McConnell's findings were to be believed, might be the next great model organism for memory research. The trouble was, it wasn't going well. In fact, no matter how hard Gershman tried to train them, none of his planarians would learn a thing. Can a worm learn? When McConnell posed the question in the early 1950s, the notion that memory had something to do with synaptic associations between neurons in the brain was just beginning to gain currency. McConnell, then a graduate student in psychology at the University of Texas, reasoned that planarians, among the simplest creatures with true neurons, should therefore be able to learn. His early worm experiments were not particularly novel. He simply substituted worms for rats in what were, at the time, standard classical conditioning studies, repeatedly shocking the worms while exposing them to a bright light. After a period of this training, the worms came to associate the light with the shock and scrunched their bodies in anticipation whenever the light flashed. Voila! Worm learning. Planarians have stranger features to offer for experiments. If a planarian is chopped in half, both halves will regrow into a new worm. The tail will grow a new head, and the head will grow a new tail. A fragment as small as 1/279th of the original worm can regrow into a completely normal adult worm in a matter of weeks. A regenerative capacity so powerful that, as one early naturalist put it, planarians are effectively immortal under the edge of the knife. For McConnell, this ability begged the question: when you chop a worm in half, do both halves remember? This is where the real worm torture began.
In the 60s, McConnell, by then a young professor at the University of Michigan, started beheading his trained planarians. The worms that grew back from the severed heads behaved as the originals had, associating the light with the shock, a result he expected given the preservation of their primitive brains. What surprised McConnell was that the worms that regenerated from headless tails remembered too. This meant that whatever form the worm's memories took, they weren't the exclusive purview of the brain. It appeared that the memories were laid down throughout the animal's body, McConnell later reflected. Thrilled, McConnell pushed his experiments further. He cut the worms into smaller and smaller pieces. Each time, the regenerated segments retained the memory. He stitched the heads of trained worms onto untrained tails, but they kept falling off. He pureed trained worms and injected them into naive recipients, a delicate process that the historian Larry Stern has compared to impale a prune with a javelin. Finally, remembering that some planarians are cannibals, he fed trained worm puree to their brethren. In subsequent trials, the cannibal worms picked up the light response right away, as though they were remembering rather than learning what to do. If McConnell's experiments appear gruesome, his line of inquiry was of his time. The discovery of the DNA helix in the 1950s had revealed just how much information is packed into proteins and nucleic acids. The notion that the physical traces of memories, or engrams, might have some chemical basis seemed plausible enough to many scientists. Could McConnell's cannibal worms have eaten an engram? McConnell certainly thought so. He was convinced that their memories were encoded in the structure of their RNA and could be transferred from worm to worm. In the jargon of computer engineering, information is always fed into a computer, the journalist Arthur Koestler later wrote in an appreciative survey of McConnell's work. Here, the metaphor became flesh. These were sensational findings, and McConnell took every advantage of the media attention they generated. Before becoming a scientist, he had had a brief career in radio, and he knew how to repackage nuanced ideas as pithy sound bites. In magazines such as Time and Esquire, he spoke grandly of a future of memory consumption, of piano lesson pills and professor burgers. He brought his trained worms onto the Steve Allen Show, and, belying his clean-cut hair and horn-rimmed glasses, dubbed himself McCannibal. Students began writing to McConnell's lab at the University of Michigan to ask for worm training tips for their school science fairs, and McConnell shared advice. Science, he believed, should be for the people. He saw himself as a latter-day David pitching stones at institutional Goliaths. This made him one of the most famous public scientists of his era, but it did not endear him to more serious peers. It also didn't help that he published all his research in the Worm Runner's Digest, a countercultural journal he distributed from his lab.
The Worm Runner's Digest was sort of Mad Magazine meets a serious scientific journal, Gershman told me recently. At its peak, it had some 2,500 subscribers around the world. The hand-drawn shield on its cover featured a two-headed planarian and the Latin motto Ignotum per Ignotius, which roughly translates to the unknown explained through the even more unknown. Its 1959 inaugural issue consisted of only 14 mimeographed pages about the care and feeding of planarians, but it quickly grew. In addition to publishing dozens of memory transfer papers and related scholarship, McConnell welcomed humor and printed science fiction stories, rousing editorials, student-drawn planarian cartoons, spoof articles, and poems. While the digest is now something of a cult classic, the mix proved confusing for many readers. McConnell eventually cut the publication in half, not unlike a planarian worm, and renamed the serious half the Journal of Biological Psychology, no relation to the current peer-reviewed journal Biological Psychology, founded in 1973. But McConnell's reputation as a heretic and prankster was well established. The wheels started to come off in the mid-1960s. Although McConnell enjoyed a period of fame and funding, including an accelerated path to tenure at the University of Michigan, attempts to replicate his memory transfers yielded inconsistent results. While many apparently succeeded, the failures were more visible. In 1965, the Nobel Prize-winning biochemist Melvin Calvin tried to replicate McConnell's worm experiments and failed, even with the help of some of McConnell's former assistants and using the same device.
His high-profile publication of the results sparked an acrimonious debate, among other things, proper worm handling. By the 1970s, the planarian memory fad had come and gone. Scientists had moved on to rats, cats, goldfish, and even praying mantises. Researchers showing successful memory transfers in rats by injecting brain RNA from one animal to another had published their findings in prestigious journals such as Nature and Science, making the planarian model seem unimpressive in comparison. But when further experiments proved inconclusive, interest in the question of memory transfer petered out. As the science historians Harry Collins and Trevor Pinch put it, memory transfer was never quite disproved, it just ceased to occupy the scientific imagination. Courtesy of Sam Gershman and Zachary Kelso. McConnell closed his laboratory in 1971, and his long period of subsequent obscurity was broken only once, in 1985, when he became a victim of the Unabomber. He lost his hearing temporarily after the blast. He died in 1990. If a younger generation of scientists is familiar with his cannibal planarians, it's as a cautionary tale that neuroscientists tell to their students at bedtime to scare them away from ill-fated projects, Gershman said. Still, McConnell's unconventional work and contrarian attitude has lingered in neuroscience lore, and the idea of memory transfer remains a subject of private fascination. What if McConnell really did manage to feed a memory to a worm? For Gershman, who is searching for a way to study memory at a molecular level and connect it to observable behavior, the question was an itch that had to be scratched. He decided to settle the matter once and for all. It all seemed straightforward enough. In the spring of 2025, Gershman and Maddie Snyder, one of his postdocs, set out to reproduce the worm training protocol of one of McConnell's students, Alan Jacobson. Jacobson's papers were the most rigorous of the planarian memory transfer era, and Gershman and Snyder followed them to the letter. We wanted a behavioral basis to be able to study the circuits that are driving memory in these extremely unstable animals, Snyder said. Are those circuits at all being used for memory consolidation or storage?
Because if you lose your head and all those circuits are gone, then what is the mechanism of storing memory? Despite their best efforts, however, they couldn't do what Jacobson, McConnell, and so many others had done back in the 1960s, condition the worms to scrunch their bodies in response to light. They reported the results on bioarchive.org in April 2026. I was really scratching my head about this, Gershman said. He'd assumed that the memory transfer would be the dodgy part of the experiment, not getting the worms to form a memory in the first place. They talked to other planarian labs. They tried different stimuli. They ran the planarian footage through a machine learning pipeline. In desperation, Kelso and Snyder even visited the Harvard Science Museum to examine a vintage inductorium, an electric shock contraption used in mid-century worm science. But it offered no clues.
Kelso searched for any of McConnell's former collaborators who might still be alive, and through a stroke of luck, he found contact information for Daniel Kimball and his wife, Reva, who had both worked in McConnell's lab. Now in their 90s, they live in Eugene, Oregon. When Kelso called them, he discovered that not only did they run most of McConnell's experiments in the 1960s, but they'd also kept the entire print archive of the Worm Runner's Digest in a box in their basement. Kelso and Snyder bought tickets to Eugene. Over the course of 2 days, while consuming plates of homemade cookies and countless cups of tea, they absorbed everything they could from the Kimballs. On breaks from hand-scanning back issues of the Digest, they went stream hopping nearby and filled casserole dishes with silty fresh water. Back at the Kimballs' kitchen table, the 2 generations of scientists watched the silt settle to see what worms might emerge. Taisaku Nogi, Dan Zhang, John D. Chan, Jonathan S. Marchant. This, after all, is what McConnell did. Rather than using laboratory strains of planarians, he sourced his from a lake near the University of Michigan. And so, not wanting to leave any stone unturned, Kelso made one final trip to McConnell's former fishing grounds in Michigan. He returned with plastic tubes full of worms, but not a single one was a learner. At some point, we had like 12 different strains of planaria, none of which showed any learning, Gershman said. As Snyder tells it, the Kimballs were absolutely convinced that their conditioning experiments in the 1960s had worked.
The worms learned. They were sure of it. The literature of the era seems to support their certainty. At least 36 labs reported similar results. So why is it that when the exact same experiments are done today, using the same laboratory protocol and even the same worms fished from the same Michigan waters, planarian worms are utterly uneducable? One explanation, Snyder said, is that McConnell, the Kimballs, and all the other worm runners were inconsistent in how they scored the planarians' behavior and may have misinterpreted more anodyne worm turns for the definitive scrunch of the light reaction. Every scientist is a product of their time, after all, influenced in myriad, often invisible ways by sociological conditions, funding pressures, and, in this case, a highly charismatic leader. This interpretation made Snyder hyper-aware of her own potential biases. Throughout this entire project, she told me, I was like, what are the things that I am taking for granted now in our models of neuroscience and our assumptions of what is known and unknown that I should really notice? A more remote possibility is that planarian worms themselves have somehow changed over the last 6 decades, falling victim to pollution or genetic drift. Gershman finds this scenario unlikely. What are the chances that a bunch of researchers just happened to do these studies at the particular time when this phenomenon happened? He asked, incredulous. They just got extremely lucky in the millions of years of planarian evolution, and then our luck ran out? No matter the reason, in 2026, despite their nervous system and simple brains, planarians don't learn. From an evolutionary perspective, this might actually make sense. The reason that we learn associations, to some degree, is so that we can predict danger and avoid it, Snyder said. But planarians have a different relationship to danger. Their regenerative physiology, so key to McConnell's experiments, protects them from blunt trauma. Bitten in half, they simply grow back. What use is memory to such a creature? That's a whole other philosophical conundrum, she said. It's a great time to be wrestling with such conundrums. Planarian learning may be a dead end, but memory transfer experiments with other organisms are back in scientific vogue, and those experiments appear to be working.
In 2018, the neuroscientist David Glanzman of the University of California, Los Angeles, performed a memory transplant on the sea slug Aplysia californica, a darling model organism for memory research, owing to its relatively simple nervous system and gigantic neurons. After training the slugs to respond to a shock to their tails, Glanzman was able to transfer the sensitization from one slug to another via a direct injection of genetic material. This suggested that some aspect of the memory was stored in RNA, which was McConnell's contention. Then, in 2021, the Princeton University geneticist Colleen Murphy found that Chironobacchetus elegans worms, microscopic roundworms with 302 neurons to their name, could learn to avoid a pathogenic bacterium by eating, or even just swimming around in,
pureed worms who had learned the hard way. Murphy's group identified a retrotransposon, a jumping segment of genetic material, called CER1, that appears to carry a memory between individuals, she said. A few years later, a group at the Indian Institute of Science published a paper suggesting that trained C. elegans worms release extracellular vesicles, small lipid particles containing genetic information, that can impart their training to their naive counterparts. None of these researchers are half as flashy as McConnell was, but their work indicates that he may have been right about worm memory after all. He just bet on the wrong kind of worm and doubled down on it, despite inconsistent evidence. In the end, he lost his reputation, but his sheer gusto sparked the curiosity of another unconventional scientist. Fortunately, this one's following the evidence. At Harvard, Gershman is shifting his focus from the inscrutable planarian to the more legible C. elegans. It may not regenerate when it's cut in half, but C. elegans is a long-standing model organism in neuroscience, and it's been consistently shown to learn. With new experiments underway, Gershman is cautiously optimistic. "I just hope we're not going down another rabbit hole," he told me. A wormhole, on the other hand, that's for certain.
Claire L. Evans leaves the listener standing on the icy banks of the Charles River with Zachary Kelso, wondering why the planarians won't perform their old tricks. It's a story about the ghost of a 1960s experiment, the idea that memory could be eaten, and the persistent hope that some biological truth still hides in those flatworms. If Evans looks at a mid-century scientific myth and sees a mystery worth solving, Ian Bogost looks at another icon from that same era and sees a trap worth escaping. The marshmallow test, much like McConnell's worms, became a cultural shorthand for how brains are supposed to function. But where the researchers in the Harvard lab are trying to get their subjects to learn again, Bogost suggests the real lesson isn't in the waiting, but in the eating. It's a striking contrast in how to handle a legacy. One piece treats a failed experiment as a prompt to look closer at the cells. The other treats a famous experiment as a reason to look closer at the clock. Read together, they suggest that the 1960s didn't just give us data. The era gave us scripts for how to live and think that are only now beginning to crack.
The cult of delayed gratification is a lie. The sensory enchantment of everyday life can upend the bland monotony of our overly optimized anodyne world. Sign up for Ordinary Extraordinary, Ian Bogost's guide to making everyday life vivid again. You'll receive the first edition of the limited-run newsletter course in early July. Eating a pint of ice cream instead of improving a difficult relationship with your partner is easy. So is scrolling social media instead of completing a cardio workout at the gym. Simple and accessible delights seem like lures that drag you away from a better life, rather than tools to help you achieve a more meaningful one. Seeking gratification, we have been told, feels good in the moment, but worse in the long run. But gratification is good, even though it gets a bad rap. People find the enjoyment that gratification offers suspicious, because it became associated with indulgence. And yes, people sometimes do pursue pleasures such as food, alcohol, drugs, porn, social media, shopping, and gambling to their detriment. Those temptations offer an easy rise that can distract pleasure seekers from engaging in more spiritually fulfilling long-term pursuits. Indulgences distract us from our goals, or even become sources of harm or destruction when they are selfish pursuits, undertaken only to please ourselves. But gratification can be pointed toward the world, the sensory enchantment of everyday life. The world is full of ordinary stuff with which you might yet commune. Doing so is easy and free. Simple pleasures are readily available and can overturn the bland monotony of our overly optimized anodyne world. The more you allow yourself to accept the weird, wonderful gifts that life constantly offers, the more their offerings will feel desirable, even transformative. Gratification is considered dangerous because it is instant, offering immediate pleasure at the cost of future benefit. We have been indoctrinated into the cult of delayed gratification. Psychologists and economists have spent decades demoting gratification to a sin. They were wrong to do so, and the time has come to reclaim a gratifying life as a virtuous one. The story begins with marshmallows. Beginning in the late 1960s, a group of researchers conducted a series of experiments on children at a local preschool.
In a typical study, a researcher would invite a preschool-age child to visit a surprise room, a prospect that could have sounded delightful rather than creepy to children of that age and of that era. The surprise room was plain, with 2 chairs and a table. A tin was placed at the center of the table, and some toys sat on the floor near one of the chairs. The researcher would then show the child the toys and explain how they worked, promising that the child would get to play with them later. Then the man would offer the tot a small treat, a marshmallow, all white and plush. He'd declare that he was going to leave the room, but that the child could make him come back whenever they wanted, although the child would then have to settle for a lesser snack, such as a pretzel. After the child understood the process, the experimenter would reveal what was under the tin. More and bigger treats, sometimes bigger pretzels and animal crackers. In one test, the researcher announced his intention to leave again, but this time the child had a choice: eat the smaller treat and make the researcher come back, or summon him to return. If the kid waited, he or she would be rewarded with a treat. The man didn't tell the children how long they had to wait, but he planned to return in about 15 minutes, a long time for someone of any age to just sit there in front of a marshmallow. No matter the child's choice, the pair would still get to play with the toys afterward. The researchers were Stanford psychologists carrying out an experiment on impulse control devised by Walter Mischel. Their experiment, which became widely known as the marshmallow test, came to represent the levers one might pull to encourage delayed gratification and to quell its presumably dangerous opposite, immediate gratification. That Mischel would hatch the marshmallow test shows just how skeptical our culture is of gratification, and was even more than half a century ago. The psychological and cognitive principle that humans are hardwired to want things and socially enculturated to desire them immediately had connected gratification with indulgence long before Mischel set out to measure temptation. Decades earlier, Sigmund Freud, the inventor of psychoanalysis, had developed a theory of the pleasure principle. Our basic human drives, which Freud called the id, seek immediate gratification for needs such as hunger, thirst, sex, diversion. And conversely, they seek to avoid the pain that comes with failing to fulfill those needs. As psychoanalysis gave way to behavioral science, the pleasure principle evolved into the concept of immediate or instant gratification. Because it is animalic and wild, the instinctual desire to gain immediate reward must be tamed and controlled. For Freud, a reality principle, related to rational action and social norms, steps in to control the pleasure principle. And in behavioral psychology, delayed gratification offers a similar restraint. When children in the marshmallow test wait 15 minutes to reap the reward of greater treats, they demonstrate their capacity to resist their immediate urges. This act of resistance is considered intrinsically valuable because it is presumed always to result in a reward. Gratification was considered a basic instinct, so to resist it was thought to demonstrate the discipline to instead pursue more substantial future gains, as one of the studies put it. The marshmallow tests were enormously influential. The experiment was run many times in several variations, and Mischel and others returned to it in longitudinal studies to see how the children who had held out for 2 marshmallows at age 3 fared at age 13 or 30. Over time, researchers claimed that those who could adopt delayed gratification at a young age were more adept, competent, and successful across a dizzying array of metrics, including SAT scores and body mass index. A purported reason? They knew how to control their impulses to delay the gratification of an immediate pleasure. That control, the theory went, allows someone to plan and execute in the more meaningful long term. Just one problem. The marshmallow test seems to demonstrate exactly nothing about an individual's success, short or long term. More recent studies, carried out amid a larger crisis to replicate research results in the behavioral sciences, have cast doubt on the findings of Mischel and his successors. It seems that the desire for a quick and simple answer,
the supposed sin of instant gratification, came for the instant gratification researchers. The studies that cemented the conclusions about SAT scores and the like were small and had been carried out with children recruited from Stanford's campus preschool, meaning that they came from educated, wealthy families who already had many other advantages beyond having delayed consuming candy a decade or more earlier.
Kids in more precarious situations, such as those accustomed to food insecurity, poverty, or the rarity of a surprise treat, might indulge gratification not on account of psychological defectiveness, but because of learned caution. If someone offers you something, grab it before they take it away again. But even among privileged children, researchers have found no evidence that being able to resist the marshmallow has had any impact on their lives. By 2020, a group of researchers that included some of Michel's former graduate students published a new study on the marshmallow test. The team surveyed 113 participants who had taken part in the Stanford studies. Well into middle age by then, the former preschoolers' lives were established, their successes and failures reasonably certain. Studying this group anew, the scientists found no evidence that long-term success on a set of capital formation factors, including education, income, net worth, lack of debt, and forward-looking behavior patterns, could be predicted by the participants' performance on the marshmallow test. As the researchers themselves put it, preschool delay of gratification does not have predictive power for our midlife capital formation variables. Walter Mischel, who died before the study was published, was one of the authors. In addition to psychologists, economists have concerned themselves with immediate gratification, which they also tend to frame as a problem of self-control. In a widely cited paper on the topic, Ted O'Donoghue and Matthew Rabin argued that people who pursue immediate gratification are expressing time-inconsistent preferences. That is, the person who chooses a gratifying activity in the present moment is correct in relation to their current desires, but wrong about their future ones. The researchers' examples of those immediate desires include activities such as smoking, overeating, and going to the movies instead of completing a report for work. Economists tend to think that people always maximize utility, seeking the greatest happiness. To them, gratification may offer a boost to that utility in the moment, but one that will only seem foolish later on. Self-control and planning are important skills for reasoning beings, but gratification does not always, or even usually, involve a choice between the present and the future. The psychologists, economists, and happiness advocates have saddled the rest of us with an impoverished and incomplete picture of gratification and its distinctive delights. For one part, it is both preposterous and oppressive to imagine that even the passing or idle moments of one's life must be optimized for long-term goals. The very idea that a preschool-aged child would need to maximize their ability to resist the treats an adult has dangled in front of them should offend you. The notion that you waste any moment not spent optimizing your life is scandalous. For another, the received idea of instant gratification is far too narrow. It splits the world into either productive work or dangerous indulgence. But in between maximizing profit and succumbing to addiction, you find a universe of other encounters. Most of them are innocuous, momentary, and meaningful. The happiness scientists and pop psychologists seem to think that gratification is something that gets used up when it is encountered, usually through consumption, as in the case of literally ingesting a marshmallow, or downing a Manhattan, or drawing tar and nicotine from a cigarette, or just scrolling Instagram. This is wrong. Gratification can arise from pleasures of the flesh, such as eating, using substances, and having sex. But it also, and far more often, takes place when you connect your senses to a thing in the world, and when you do so fully and consciously. Gratification is not the pleasure that you indulge now at the expense of what you might do in the long run, but the pleasure you can encounter only if you do so right as it happens, or else it will pass you by forever. It is always immediate and never deferred. You can't put off the unique pleasure of eating or squashing or melting a marshmallow, because to indulge in that pleasure is a quick and easy act that takes place in the present.
You can forego, miss out on, or ignore gratification, but delaying it is impossible. To do so is to pursue a pleasure of a different kind. The marshmallow test researchers tempted children with a treat if they could just wait for it. But eating 2 marshmallows later instead of 1 right now is more a test of satisfaction than of gratification. The delight comes from waiting out 15 minutes of boredom in anticipation of the adult's return, eating the 2 marshmallows, and playing with the toys as promised.
Lost in all the hand-wringing by positive psychologists and happiness consultants is any consideration of what a 3-year-old subjected to the marshmallow test could easily tell you about actual marshmallows. They are delightful, and in so many ways. Marshmallows are pleasant to eat, for starters, but not just to eat, also to hold and to behold. The mere existence of a marshmallow is a miracle. I can't believe the researchers would have forgotten. A cloud of sponge sugar, weightless, textured like leather but soft like petals. It floats on cocoa. It squishes monstrously. You can draw a face on it with chocolate sauce. Perhaps the least interesting thing about marshmallows is their suitability for longitudinal studies of personal achievement. The marshmallow test publications speak about the treats offered to the kids abstractly. A marshmallow, a small pretzel, when the specifics matter. By 1967, when the tests began, mass-produced marshmallows were available in both large and mini sizes, and the small ones were at times used in the studies. Does a single mini marshmallow even count as a treat? Maybe the kids were just being polite, trying to meet the unhinged expectations of the strange men who lured them from the comfort of preschool into the curious guiles of their surprise room. And that's just one aspect of the gratifying gastronomical features of marshmallows. I'm not saying I dislike the things, but to me, the sweetness is so strong and the flavor so one-note that I find myself more inspired by their unique texture and supple form. If you have some in the pantry, go get one right now and put it in your mouth for a moment without eating it. Feel its malleability between your teeth, how its squashy fragility, marshy like the plant from which it was originally harvested, gives a bit before bouncing back. This squishy honor of a marshmallow doesn't even require devouring it, the indicator that psychologists took as the signal of its depleted future life. Just hold one between your fingers and compress it a bit. Then crush it entirely, witnessing its slightly drier exterior crack like Dust Bowl cropland before it explodes into an oozy splatter. Were the children subjected to the marshmallow test allowed to pursue such gratifying delights? Or would merely touching the treats have demonstrated their surrender to short-termism, causing the psychologist who gazed at them through a peephole to return disappointed? If ever you have encountered a marshmallow, the sight of one might call to mind these and other properties. Memories of encounters you might have looked past, or perhaps even felt ridiculous admitting you had enjoyed, let alone revealing to someone else. Once, many years ago, I saw a strange, experimental short film at a festival. The film showed a bowl of soup, and then a hand dumping oyster crackers into it, something of the pottage equivalent of marshmallows in hot chocolate. The camera kept rolling until the oyster crackers had evaporated into the soup. But the film was structured to cut from soup to soup, first split pea, then ham and bean, and eventually tomato, such that the crackers took less and less time to melt. When the screening finally reached tomato, and the crackers vanished nearly instantly, the crowd erupted in cheers and applause, so gratified to see the outcome that their prior but unsurfaced experience with soups had made comprehensible and then delightful. All of us have probably experienced the urge to pull away from something we ought to do for the sake of long-term satisfaction or happiness, finishing a work project to realize part of a career plan, checking in on your parents in another city, hitting the gym to forestall the inevitable decay of mortality. While I've been writing this, I've stopped numerous times to retrieve a refreshment from the kitchen, to swap out a lampshade for a new one delivered to my door, and yes, to scroll my phone in search of diversion. But that doesn't mean that artificially sugared sodas, retail consumption, or social media are depraved, worthless activities akin to the cardinal sin of sloth or the tragic spiral of heroin addiction. Instead, pleasures are always braided.
We pursue happiness, satisfaction, and gratification all at once in different ways. Our tactile and sensory life has been de-emphasized in favor of ideas, symbols, accomplishments, and abstractions. But why not revel in sensation? For one thing, these activities take up so little time, just a few minutes or even a few moments. For another, these moments often take place in circumstances when no other options are possible. What is a woman, delighting in the sensation of her fingers contacting her car's steering wheel, meant to do instead of encountering that object she absolutely must be touching to operate her vehicle? It costs her nothing and demands no trade-offs.
If anything, the momentary delight helps make up for a source of unhappiness, her long and arduous commute. Much of the time, opportunities for gratification simply arrive at your feet. They do so constantly. Done right, you can't help but take advantage of them. Think of gratification the way you think of humor. Like laughter, gratification is involuntary. Have you ever tried to suppress a big, guttural laugh upon hearing a funny joke or catching an unexpected sight? Your whole body rebels against the effort. You cannot bottle up laughter or gratification in the hopes of optimizing its usage later. The same features that make the psychologists and economists worry that pleasure is a low and basic response of the animal brain also make gratification a thing that happens when things happen to you, provided you are open enough to witness them. Gratification offers a way to express the mismatch between your body and the rich, dense universe of things that are outside your body, but that it nevertheless encounters. It is the good feeling you get from resolving the absurdity of the sensory world. There you are, touching an escalator handrail, which bobbles slightly in its track. There you are, having crushed an oak gall underfoot on the way to the mailbox. There you are, your fingers zippering across the sleeves of garments hung close together on a boutique rack. For happiness theory, pleasure is acceptable only when it gets promoted to higher meaning. But the connections and the communion available to us as human beings are not limited to interacting with other human beings. You won't develop the kind of relationships with steering wheels, coffee cups, and oak galls that you can develop with your children, your neighbors, or your community. But why should that stop you from forging the most and the best connections with all of the other objects you might encounter? Pursue more relationships of a different kind for the purpose of another type of contentment. Happiness and satisfaction are hard, but gratification is easy. This essay is adapted from Ian Bogost's forthcoming book, The Small Stuff: How to Lead a More Gratifying Life. When you buy a book using a link on this page, we receive a commission. Thank you for supporting The Atlantic.
The ground shifts when the icons of the psych lab, the ground-up flatworms and the lonely marshmallows, lose their status as truth. There is a freedom in seeing these mid-century myths crumble. Memory might not be a locked vault in the brain, but something fluid and chemical. Just as the choice to eat the marshmallow might be a refusal to trade the present for a promise. What lingers is the vastness still hidden under the skin. If the old maps of how people work are wrong, what else is being missed by looking for order where there is only life?